All right, so here we have a prototype robot takes 1 minute to accelerate to 10 miles per hour, which is 880 feet per minute. Then the robot maintains that speed for 2 minutes and then takes half a minute to come to a complete stop. The robot's acceleration and deceleration are constant, so basically linear, and the figure shows the robot's speed. So here, what we're doing on the left side here, we're accelerating up here, then we remain a constant here, and then we decelerate over here. Okay, and what we're supposed to do is calculate the area of the shaded region between the graph and the horizontal axis. And then what is the practical interpretation of the area found in part A? Well, we have three different types of shapes here. We have a triangle here, then we have a rectangle, then we have another triangle. So what I suggest is call that region 1, call that region 2, and call that region 3. So for A, we're going to have to calculate all three regions, and then after that, we can actually add those regions together. So for the triangle, R1, what is the area of a triangle? Well, area is equal to 1/2 base times height. And so what's that going to be equal to? Well, 1/2 times, well, our base is 1. Our height is 880. Well, half of 880 is 440. Now, what are our units? Well, this is feet per minute times minutes. And so the minutes cancel, and so this is going to be 440 feet. Okay. So what about R2? Well, that's going to be area is equal to length times width. And so here we're going from 1 to 3. So 3 minus 1 is 2. So that's, I don't know if we want to call that the width or the length, but it's 2 times. And then we have 880. Okay, so 2 times, that's going to give me 1760 feet. Again, we have feet per minute times minutes. Minutes cancel, we get feet. And finally, our R3, our area again is going to be 1/2 base times height. So it's going to be 1/2 what? Well, now we're only going to have a half. So a half times times our 880. So basically, we're going to have a quarter of that. So 4 goes in that, 220. And so that's going to be 220 feet. And so what we have now is going to have the area total is equal to R1 plus R2 plus R3. And so that's going to be 440 plus 1760 plus 220. And so that's going to give us a total of 2420, it looks like, feet. Okay. So that's everything under that curve, all the blue. Okay. And so we have the total, so that's what we wanted for A. B says, what is a practical interpretation? Well, what is it? Well, the area is going to be the distance the robot travels in the total time. So because each time he's traveling, he's speeding up for this period, but during that time he's speeding up, he's actually traveling a distance. Then he goes a constant speed for a while, he's traveling more distance, and then he decelerates and he's traveling more distance. And so you can see when he's accelerating, the distance is getting bigger, and when he's decelerating, the distance is getting smaller as far as if you think about it compared to the axis up here. So, this piece is a lot bigger than this little piece, and, that looks about like it's about the same except for the acceleration. But what we can say is the area in part A is the distance the robot travels in, and he traveled for 3.5 minutes. And that distance is 2420 feet. Okay. And again, this is why this section is easy, because we have these nice formulas we can use and we can get our actual values. Now in the next one, we're going to have to do a little bit different, and we won't have nice formulas. We'll have to do something different as far as how we calculate that area under the curve. All right, so I didn't know if I need space here, so let's go on to the next one. So the next one says a rate of change in the net earnings of GAAP from 1992 to 2001 can be modeled as follows. And we have, two pieces here. We have a part one is from 0 to 9, and we have a part that's just from 9 to 11. So we're basically, from this 9 to 11 years, it's decreasing only, whereas here we're actually increasing. So G prime is a measure measured in millions of dollars per year, and T is the number of years since 1990. The figure shows a graph of G prime, which is over here. So we have, it looks like, again, 3 regions. This region is negative. We'll call it region 1. This region is positive, and this region is negative again. Okay, so we're supposed to calculate the area of the region lying above the axis between the graphs of T. Then calculate the total area of the regions lying below the axis and the between the graph and the t-axis, and then use the answers in part A and B to estimate how much GAAP Inc. earnings changed between 1990 and 2000. All right, well, what's going to happen here, and I don't think that's supposed to be 1990 and 2000. It's probably... Okay, so yeah, so it's since 1990 and to 2000. Okay, they just have different things here. All right, so what are we going to do? Well, we have to calculate those areas. And I think what we're just going to do is we're just going to calculate area 1, area 2, area 3, because that's part A and B, but we'll just go from left to right. So the first one here, it's going to be a negative value because we have this negative region. This is going to be a negative area, but remember, area actually overall is going to be positive. It's just going to be the earnings are going to be a negative value. The area is going to be actually a positive value. So for R1, what do we have? Well, again, we have a triangle. So area is equal to 1/2 base times height. And so we have 1/2 times our base. Well, our base is going to be down here. So that's going to go from here to here. Well, we can get this value from our original equation. That was a negative 133.31. So negative 133.31 times, and our height. Well, our height goes from here to here, which is 2.9. Okay. So if we plug that into our calculator, we get, it looks like, a negative 193.2995, and that's going to be dollars, and it's going to be millions. Okay. And so again, the actual area is going to be just a positive 193.2995, but because we're taking it in relation to what the earnings are going to be this negative value, but the actual area itself is positive. Now R2, what is that going to be? Well, that's again area of a triangle, so 1/2 base times height, so 1/2 times. Now, what is our base? Well, our base is going to be this here piece. And so what we're going to have to do is we're going to have to plug in and figure out what that's equal to. So that's going to be G prime of what? Well, that looks like it's at 9. And so that's going to be our 45.86 times our 9 minus that 133.31. And so that gives us 279.43. And so that's 279.43. And our height, well, that's going from 9 to 2.9. So we just take our 9 and subtract off our 2.9, and we get our 6.1, it looks like. And so if we multiply all that together, that gives us a value of, it looks like 852.26, we better write this down, 852.2615 million, okay? And it's a positive, so the area and the revenue are both positive here. Now what do we have? Well, now we have R3, And area here is going to be what was length times width, wherever we call length and whichever one we call our width. And so what do we have here? So we're going, it looks like this is our value here. So that's going to be the negative 567. So I have a negative 567 times, and we're going from here, it looks like 11 to 9. So that's going to be a 2. And so if we multiply that, that's going to give us a negative, well, we'll put a dollar sign, a negative 1,134 million. Okay. All right, so now it did ask for the total area below. So we really do have to calculate that. So area below, R1 plus R3, that's going to be our negative 193.2995 plus negative 1,134. And so if we add those together, we get, it looks like it's going to be a negative 1,327.2995. All right. And that's going to be $1 million again. So it's a million. But the actual area is going to be a positive 1327.2995. Okay. And again, it's going to be, the area is going to still be millions of dollars, but we have to call it a positive to get the actual area. Okay. Now, part C. Oops, wrong way. Part C says use the answers in part A and B to get the actual earnings. And so what we're going to do is we're going to take our, what is that, R2 plus our A, which we found here. And again, we're going to use that negative in this case. So we're going to have positive 852.2615 minus 1327.2995. And that gives us, and it looks like it's going to give us a negative $475.038 million. Okay. And so basically, what does that mean? If it doesn't say to interpret it, but we can say earnings basically went down $475.038 million. Okay, so that's how much it went down. So that's where we are. Our earnings went down over that period of time, $475.038 million. Okay, so I think now we've answered everything. All right, let's stop here and we'll come back for more.